Today we're going to learn section 5.1, angles of triangles. So to start with, we're going to start with classifying triangles. So you can classify triangles by angles and by sides. So if you want to classify triangles by its angles, you have to know what kind of angles are in the figure. So if we look here, we've got a triangle. All three angles are acute. So we would consider this triangle an acute triangle. This next one, all three angles are obtuse. Remember, obtuse are angles that are more than 90 degrees, so we call this an obtuse triangle. And you can see these next two. If you have a right angle, the triangle is called a right triangle. And then if you have three congruent angles, we call it an equiangular triangle. So if all three angles have to be equal, and they all have to add to 180, how many degrees would each of those equal angles be? Hopefully you said 60. So all three of these angles would have to be 60 degrees. Okay, so now we're going to talk about classifying triangles by its sides. Whenever you have three sides that are all the same length, we consider that triangle equilateral. Whenever it has at least two congruent sides, we call it isosceles. And then whenever we have no congruent sides, we call it scalene. So equilateral, I think we can remember pretty easily. All the three sides are equal, right? Isosceles. So to help you remember isosceles, how many eyes do you have? Now I know it's not spelled eyes, right? Isosceles. But you have two eyes, and so you have to have at least two congruent sides. So hopefully that will help you remember that. And then scalene, all three sides have to be different lengths. All right, so in each of these examples, we're going to classify each triangle by its angles and its sides. So if you look at this first example, we have a right angle. We have two equal sides. So that would be a right isosceles triangle. If you look at this top middle one, we have three angles that are all less than 90. So that makes the triangle acute. And then looking at the side lengths, are any of them the same length? Since they're all different, this is an acute scalene triangle. Looking at the next example here, all three angles are the same. Since they're all the same or they're all equal, they would be equiangular. And then if you look at all three sides, they all happen to be 3 millimeters, so they're all equal again, so they are equilateral. Looking at this next example in the bottom left, you can see we have an obtuse angle. Right 97 is greater than 90. And then since two of the sides are the exact same length, this is obtuse isosceles triangle. All right, this middle bottom one, we've got three angles that are all the same. So we've got equiangular. And then all three sides have a length of 7. So this is not only equiangular, it's also equilateral. And then our last one here, we've got a right angle. So this is a right triangle. Then all three side lengths are different lengths. So this would be a right scalene triangle. All right, so in this next example, we have to classify the triangle by its sides and determine whether it is a right triangle or not. So whenever you're doing one of these on the coordinate plane, you have to find the lengths of the three sides, and you have to find how steep the sides are. So basically you're finding their slopes. So you can use the distance formula to find the side lengths. You can use perpendicular slopes to figure out if you have right angles. So we're going to calculate all three sides side lengths and all three sides slopes. All right, so let's go ahead and take a look at the side lengths. So we're first going to calculate the length from P to O. So I want you to practice writing out all your work. So as you can see, we can do PO equals, remember this is that distance formula. So remember your x's go in the first set of parentheses, your y's go in the second set. So we're doing -1 minus 0, and then 2 minus 0. So that ends up giving me -1 squared plus 2 squared. So 1 plus 4, which is the square root of 5. So PO equals the square root of 5. Do the same thing for the other side links. So let's go ahead and do PQ. So P to Q, we've got -1 and 6 in there, and 2 and 3. So I end up with -7 squared and -1 squared. So 49 plus 1, which is the square root of 50. So PQ is the square root of 50. Okay, and then last here we have to do OQ. So the distance between 0 and 6 using our x's, our y's are 0 and 3. So we end up getting the square root of 36 plus 9, right? -6 squared is 36, -3 squared is 9. So we get the square root of 45. So if we look at all three of those side links, square root of 5, square root of 50, square root of 45. Since all of them are different side links, we know this is going to be a scalene triangle. Now we just have to check their slopes. So recall the slope formula, y2 minus y1 over x2 minus x1. So we're going to do that for each of the three sides. So to calculate the slope of side PO, we've got y2 minus y1, so 0 minus 2 over 0 minus -1. We end up with a slope of -2 over 1. So our slope is -2. We'll do the same thing for side PQ. So remember, M stands for slope, so the slope of side PQ, again, it's y2 minus y1, so 3 minus 2 over x2 minus x1, so 6 minus -1. So we end up with a slope of 1/7. And then we're going to check the slope of OQ. So we end up with 3 minus 0 over 6 minus 0. So we end up with 3 over 6, or 1/2. So looking at those three slopes, we have opposite reciprocals with -2 and 1/2. So that would mean that PQ is perpendicular to side OQ. So we end up with a nice little right angle right here. So we can say we have a right triangle. So in the end, when you're done with this, when it says classify it, we're going to say this is a right scalene triangle. All right, so I want you to try this one on your own. Again, it says classify it by its sides and determine whether it is a right triangle or not. So you need to go through and find the distance for all three sides and the slope for all three sides, and then determine what the answer is. So go ahead and pause the video here, and then have the kids try this, and then show them the solution in just a moment. All right, so make sure you pause the video here. All right, so hopefully we ended up getting these same side links that I have. So AB should have been the square root of 53. BC should have been the square root of 40. And then AC was the square root of 17. So since all three side lengths are different, this would be a scalene triangle. And then looking at our slopes. AB's slope was -2/7. BC's slope was 1/3. And AC's was -4. So are any of those opposite reciprocals? No, right? So this is just a scalene triangle, not a right scalene. All right, so we have a couple definitions to go through for finding angle measures in triangles. You need to know that interior angles are the angles inside of the triangle. So they're the angles that are inside, right? Whereas exterior would be outside. So you can technically change any triangle to have extra angles if you just extend the side out. And that's the angle on the outside. So I could technically have done that here. Just extend one of the sides out. And then I also have exterior angles. So if you look, the interior angle and the exterior angle together are a linear pair. So if you knew that this interior angle is, let's say, 60, the exterior angle would have to be 120 for the two to add up to equal 180. All right, so we have a theorem called the triangle angle sum theorem, and it says the sum of the interior angles in any triangle equals 180. So the measure of angle A plus the measure of angle B plus the measure of angle C must equal 180. I know you've learned that in previous math classes before. All right, so we're going to go through some examples. So if we already know the angles with two angles of this triangle, all we have to do is subtract the two we know from 180 and we can find out the measurement of angle 1. So 180, take away 24, take away 37, gives us 119 degrees. So the measure of angle 1 is 119 degrees. All right, so this next example is a little bit more difficult. It wants you to find angles 1, 2, and 3. So if you use what we just learned, you can see this triangle up here gives you 2 out of the 3 angles. So hopefully you can find angle 1. So go ahead and do that now. Figure out what the angle measure will be for angle 1. Hopefully you're getting 51 degrees. If you subtract 61 and 68 from 180, you get 51. Now, to find angle 2, you have to remember what type of angles these are. Vertical angles, right? Vertical angles are always equal, so angle 2 must also be 61 degrees. And then, to find angle 3, you use the right angle here and the 61 degree angle and subtract it from 180, just like we did in the beginning with that first triangle in red. So 180 minus 90 minus 61 gives us the angle 3 must be 29 degrees. Okay? So in this example, we can use our right angle and the fact that all 3 angles add to 180 to write an equation. So 2x's added with 90, added with the angle that's x minus 6. All 3 of those angles must add to equal 180 degrees. So now you just have to solve this simple algebra 1 equation. So remember, you want to combine like terms. So we've got like terms with 2x's and 1x, so that gives us a total of 3x's. And then we have 90 and negative 6, which would combine to give us positive 84. Then I'll bring down the equal sign in the 180. Then I can move the 84 to the other side by doing the opposite, right? Subtract 84. That will wipe it out. And of course, whatever you do to one side, got to do the other. So 180 minus 84 is going to leave us with 96. And then on the left side, I still have 3x's. So now that our equation is 3x equals 96, I can divide by 3 to get x alone. So I end up getting x is 32. So this angle would really be 2 times 32, so 64 degrees. And then this angle would be 32 take away 6, which would be 26 degrees. And if you add 90 and 64 and 26, guess what you get? 180, right? Because all three angles in every triangle have to add to 180. All right, so you're going to do the same exact thing here. Add up all of your three angles and set them equal to 180. So we have 4x minus 22 that we're going to add with the next angle, P, 10x minus 4. And then we're going to add it with angle R, which is x plus 11, and it should equal 180. So just like last time, we're going to add up all the like terms. So 4x's plus 10x's would be 14x's, plus 1x would be 15x's. And then we have to add up negative 22 and negative 4 to give us negative 26. And then negative 26 plus 11 would be negative 15. And equals 180. Now we can move our like terms to be on the same side. So we can add 15 to both sides. So now we have 15x's equals 195. And then to get x alone, we just divide 195 by 15. So we get x equals 13. So then it says find angle P, angle Q, and angle R. So to find angle P, we have 10 times our x, which is 13, take away 4. So 130 take away 4 would be 126. So angle P is 126 degrees. Angle Q is going to be 4 times x minus 22. So 4 times 13 would be 52 minus 22 equals 30 degrees. And then we have angle R. Angle R is just x plus 13, or sorry, x plus 11. So 13 plus 11, which would be 24 degrees. And then, of course, you can do a quick little check. Do all three of those add to 180? If they do, you did it right, which they do. They equal 180. All right, so this brings us to the exterior angle theorem. Remember, the exterior angle is the angle on the outside, the exterior. So this is going to help us find angle 1. Okay, again, remember, any an exterior angle can be formed by just extending the side of just one of the sides of the triangle. So an exterior angle is always equal to the sum of the two non-adjacent interior angles. So if our exterior angle here is angle 1, it's going to equal the other two angles that aren't right next to it added up. So angle 2 plus angle 3 would equal the one on the outside. So knowing that, if I already know that these two non-adjacent angles are 76 and 52, all I have to do is add them, and it equals angle 1. I can also use that fact to come up with the other angle over here. Okay, so technically, you could subtract the 104 from the 180 to figure out this angle. So 104 take away, or 180 take away 104 would be 76. And then, yes, you could subtract those two angles from 180. That's technically something you could do. You could also take 104 and subtract 79 from it, and it would equal angle 1. Either way, whatever way you want to do it. So if you do take the exterior angle, you subtract the one non-adjacent angle, it should equal the other non-adjacent angle. So 104 take away 79 leaves you with 25. So angle 1 would be 25 degrees. Again, if you don't like that way, you could subtract 104 from 180 to get that this angle right here is 76, and then you could subtract 76 and 79 from 180. You get the exact same answer. So 76 and 79 would add to 155, and then 180 take away 155 gives us 25. Okay, so sometimes you're given problems that involve algebra. So as we have before, the exterior angle equals the two non-adjacent angles added up. Okay, so our exterior angle is 2x minus 5. That's going to equal the other two angles, 70 and x, added up. So we just need to solve for x. So we can move our like terms so that way they're on the same side. So I'm going to move the x to be on this side with 2x. And then I'll move the 5 to be on the other side with the 70. So we get x is 75. And then now that we know x is 75, we can find angle JKM. So angle JKM. It's the exterior angle, right? So 2x minus 5, so 2 times 75 minus 5. 2 times 75 is 150. And then take away that 5 leaves me with 145 degrees for angle JKM. All right, so why don't you go ahead and see if you can come up with the equation here for this next example. Remember, you always start with the exterior angle. So 18x minus 15 equals, and then you have to add up the other two. So 18x minus 15 equals the other two angles added up. So 13x minus 11 added up with 4x plus 1. So just like before, combine like terms. So I'm going to combine like terms on this right side of this equation, right? So that ends up giving me 17x's, and then the negative 11 and the positive 1 becomes negative 10. All right, so now we need to get our like terms on the same side. So I'm going to move my x's to be on the left side of the equation. So I'll subtract 17x's. And that will leave me with x minus 15 on the left side and negative 10 on the right. And I'm going to move my constant so that way they're on the right side of the equal sign. So we get x equals 5. All right, so first angle it wants us to find here is angle CAB. So CAB. So we have 13x minus 11, so 13 times 5, take away 11. So 13 times 5 is 65, and 65 take away 11 is 54. So angle CAB is 54 degrees. Then we have angle ABC. So ABC. So 4 times our x, which is 5, plus 1, so 20 plus 1, so 21 degrees. Then we have angle ACB. So ACB is not given to us. We're going to have to figure that out. But since we know each of these ones are 21 and 54, we can subtract them from 180. So all three angles add to 180. So 180 take away 21, take away 54, leaves us with 105 degrees. So ACB is 105 degrees. And then we have DCB, which is our exterior angle. So there's two ways you can do this. You could plug in 5 in for x and solve, or you could add up your two non-adjacent angles. So 54 plus 21 would equal 75 degrees. So just to prove it, 18 times 5 is 90. And 90 take away 15, 75. Okay? All right, so now we're on to our very, very last example here. So we're given a word problem. It says, in a right triangle, the measure of one of the acute angles is 12 more than 3 times the measure of the other acute angle. Find the measure of each acute angle. As I always tell you, whenever you're given a word problem, always draw a picture. Okay, always make sure you are drawing a picture. So since it told you you have a right triangle, you should probably draw a picture of a right triangle. Now, I told you guys this before, we always call one of the smaller angles x. Okay, and then we're going to use the language in the problem to come up with the other angle. So if one of the angles is x, and the measure of one acute angle is 12 more than 3 times the measure of the other acute angle, which is x, we should be able to come up with an expression to represent that. So 3 times the other angle x would just be 3x. But we don't want just 3 times the measure of the other acute angle. We want 12 more than 3 times the measure of the other angle. And more than means add. So we want to take 3x and add 12 to that amount. So there's our equation. Add up all 3 angles equals 180, and you're done. So 90 plus x plus 3x plus 12, right? I'm adding up all 3 angles to equal 180. And then we just have to solve this thing. All right, so like terms, we've got 3x's and 1x become 4x's. We have 90 and 12, which we will add up to equal 102. We can move our like terms so that way they're on the same side. So now we have only 4x's on the left side, and then 180 take away 102 would leave us with 78. And then to get x alone, when it's 4 times x, you divide by 4. And that gives us x equals 19.5. So thinking of this situation, if x is 19.5 degrees, we can solve for the other acute angle as well by plugging it in or subtracting 19.5 and 90 from 180. So if you wanted to plug it in, it would look like this. So 19.5 times 3 is 58.5, and then plus 12 gives us 70.5 degrees. Okay, or you could just do 180 minus 90 minus 19.5, and you would also get 70.5 degrees. So it says find the measure of each acute angle. So one angle would be 19.5 degrees, the other one would be 70.5 degrees. All right, that's it, you guys. We have a worksheet for homework, so make sure it is done and ready to be checked in on Tuesday before class starts. Have a great day.